So now when you look at this question number 9 is basically you got to find out they have given certain points through which it passes and you have to use technology to find the quadratic model connecting y and x and then find the maximum height reached and then they say that the 1 meter high boundary fence is 75 meters away. Will the ball clear the boundary fence? So what we're going to do is we are going to first find out using technology what's the graph equation that we have. So it passes through 10, 9, 20, 15.15, 30, 19. So we can make up three simultaneous equations. But I want to also show, I'll show with both the approaches how to get the equation. One is called as regression approach, other is called as quadratic modeling using simultaneous. So obviously what we can do is, since it passes through 20, 10 and 30, so it'll be, let's say quadratic is ax squared plus bx plus c. So you're going to plug x as 10 and y as 9. So that's the first equation. So 10 squared a plus 10b plus c equals to 9. That's the first equation. Then 400, when you plug x is 20 and y is 15.25. So when x is 20, so 20 square a plus 20b plus c equals to 15.25. And last equation is when you plug x as 30, so 30 square a plus 30b plus c equals to 19. So these are the three equations. One, let's say 2, and of course, like we got 3 here. Now we can plug this on calculator under equation and you'll get the values of a and b and c. So this is one way to do it. And what we have now is, there's another way to do is directly on regression curve. So I'm just going to write down the coordinates. So the coordinates that we have is, so it's 20, 15.25. So it's 20, 15.25. Then we got 10, 9. It's 10, 9. Then we got 20, so we got 20, 30, 19. So 30, 19. So we can just put this under regression. If you put under statistics, so if you put under statistics, you get this is 20 and corresponding y is 15.25. So 15.25. Then you got x is 10. So x is 10 here and y is 9. And when x is 30, y is also 19. So you have put this now. You can just press graph 1. So you get like a general idea about where are the points. Then press calc. You will see that there is an x squared regression here. So press x squared, and you can see the equation that you will get to passing through these points. So we get the equation as y equals to minus 0.0125 x squared plus x and plus 0.25. So this is straight away, you can just get a quadratic equation or cubic equation according to your requirement. Now, also you can draw the graph of this. You can just click on draw and you can see how does the graph look like. Now, I wanted to find out, I wanted to solve the next question is that what's the maximum height reached and all. So I'm just going to go and graph this on normal graph function. So I'm going to graph this particular equation. And so here's the graphing of this part. So let's say it is negative 0.0125 x squared plus x and plus 0.25. So that's my model that I had got. If you press view window standard, you get like this. Press zoom and auto. Let's see what we get. So still it is like that. Make the Y windows a little bigger. So make it like maybe up to like 100 or something and see what happens. Make the X larger, maybe up to 30. and see how does your graph shape up. So this is a graph of the problem that we have done. Now you press, let's say, gsolve max. So if you press gsolve max, you can see the maximum occurs at x equals to 40, and the value of the y is 20.25. So the maximum height that is reached is 20.25. Now the question is that there was a hurdle at 75 meters. There was a hurdle at 75 meters, which is like 1 meter high. Will this particle crash into it or will it not? That's what we find out. So what I'm going to do is, for this problem, I'm just going to find out whether, so if you press trace button, if you press F1, and you can just plug in 75, so you get the height to be around 4.9 meters. And the boundary that you have is just around 1 meter. So it will cross above that, and hence it will be able to land on the ground. So this is one of the example of real life modeling. You can get like cubic equations, you can get an exponential equation. But if you use technology effectively, you can see that in regression, while you're doing regression, you can see that when you graph and all, if you go under the graph, statistics and do the regression. So if I go under regression, graph one, cal, you can see cubic modeling also. If you see there is not enough of elements. So if they ask you, like, you can do sinusoidal modeling, sine cos modeling as well. So this is a way to do it, how to, on modeling on this particular graph. Now the real life applications, you need to, of course, practice some more questions.